Hi, in this lesson we're going to work with how to solve one-step equations. So you ready? Let's begin. Before we actually work with how to solve one-step equations, we have to understand that in solving one-step equations, we have to know all about inverses. Inverses, or as other teachers may like to think of it as, what is the opposite? So the first four inverses that you want to focus on are the inverses of addition, subtraction, multiplication, and division. Pretty much what are the opposites of, for example, adding, subtracting, multiplying, and dividing. So the inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division is multiplication. So that means when you're solving a variable and trying to isolate and get it by itself, we have to always have an inverse operation, or pretty much the opposite, to do on both sides. And that's going to help us solve it. So you ready? Let's get started. In the first problem, we're going to have x plus 6 is equal to 12. And they're asking you to solve for x. Well, you have to ask yourself, is x by itself on one side? It's not. There's a plus 6 there. So you have to ask yourself, what is the inverse, what is the opposite of adding 6? Well, we said the inverse of addition was what? Subtracting. So what am I going to do? I'm going to have to subtract 6, not just to the left side, but also to the right side. Why? Because that's where the opposite side of the equal sign is. So what do I like to do to kind of help us solve it? I like to draw a line right where the equal sign is, so that I know that if I do something to the left side, I also have to do something to the right side. What am I going to do to both sides? The inverse. The inverse of addition was subtracting, and that's why I subtracted 6 to both sides, and I got x is equal to 12 minus 6, which is 6. And that's my final answer. X is equal to 6. Okay? Let's try example 2. X plus 5 is equal to 3. So what's the first thing I'm going to do? I'm going to draw a vertical line where the equal sign is so I can separate the left side and the right side. I'm going to ask myself, is x by itself? No. There's a plus 5. So ask myself, what's the inverse? What's the opposite of adding 5? It's subtracting 5. So I'm going to subtract 5 not just from the left, but from both sides. So I'm going to subtract 5 from the right side as well. Now when I subtract 5 to both sides, I'm going to get the 5s to cancel out, and I have x is equal to 3 minus 5. Now remember, from pre-algebra, when you're subtracting, one negative always represents subtracting. So when you have 3 minus 5, just do 5 minus 3. 5 minus 3 is 2. 5 is bigger, so because 5 is bigger, it keeps the sign. So my answer is x equals negative 2. And that's my answer. Let's work on example 3. X minus 6 is equal to 18. They're trying to isolate x, so I'm going to draw a vertical line so that I remember to do the inverse on both sides. What's the inverse of minusing? It's adding. So I'm going to add 6 to the left, but I also have to add it to the right. Why? Because whatever you do on one side, you have to do the same operation on the other side. So the 6s are going to cancel on the left-hand side. I'm going to have x is equal, 18 plus 6 is going to be 24, and that's my answer. X equals 24. Remember, in any problem that we're doing, stop the video, try it, and see if you get it right. Example 4. X minus 5 equals 11, then x is equal to, once again, draw a vertical line with the equal sign so that you don't forget to do anything on both sides. It says x minus 5. What's the inverse of minus 5? I'm going to add 5, so let's add 5 to both sides. But on the right side, it's a little bit trickier. The negative 5 and the 5 on the left side is going to cancel out because they're inverses. They always cancel out. I'm left with x on the left-hand side. Now I have negative 11 plus 5. One minus sign, right? You see one minus sign in the problem. What do you do when there's one minus sign? You subtract. So I'm just going to subtract normal. 11 minus 5 is 6. But then I have to remember, I have to keep the sign of the bigger number. In this situation, like a negative 11 plus 5, 11 was bigger. So it's going to be negative 6. And that's my answer. Not bad? Okay, example 7. If 3x is equal to 30, then x is equal to, what are we solving? We're solving for x. Is x by itself? It's not. What's next to x? There's an equal sign. And there's a 3. Left of the equal sign, there's a 3x being attached by multiplication. So what's the inverse? What's the opposite of multiplication? It's division. So what am I going to do? I'm going to divide both sides by 3. The left side, the 3's are going to cancel out nicely. I'm left with an x equals 30 divided by 3, which is 10. You're going to notice I didn't draw my vertical line this time. Why? Eventually, I don't want you to draw the vertical line. Trust yourself in the process of knowing whatever you do something on the left side of the equal sign, you're going to do the same thing on the right, or vice versa. X is equal to 10. In example 6, 6x is equal to negative 18. Then x is equal to, let's draw the vertical line this time. 6 and x are together, they're attached, so what does that mean? You're multiplying. What's the inverse of multiplication? It's division. So let's divide 6 to both sides. Why? Because I always have to do something to the left and the right, not just one side. The 6's are going to cancel out. It leaves me with x equals 18 divided by 6. You're going to notice I didn't take the negative. Why? Because 18 divided by 6 is 3, and when you divide by one negative in the problem, same thing as multiplying, your answer is always going to be negative. Okay? So when you divide by one negative, it remains negative. So what's my final answer? X is equal to negative 3. Example 7. If x divided by 2 equals 4, then x equals. So ask yourself, what's happening in the problem? There's a division symbol because that's a fraction, x divided by 2. So what's the inverse of division? It's multiplication. So I'm going to multiply both sides by 2. You're going to notice I didn't draw my vertical line because I know now that I have to do the same thing on both sides. But if you want, draw it so that you remember left and right have to be the same operation. The 2's are going to cancel out nicely because they're inverses. X is equal to 4 times 2, which is 8. And that's my final answer. How are we doing? Are we doing okay? All right. Last problem. If x divided by 3 is equal to negative 5, then x is equal to, so ask yourself, we have to solve for x. Let's draw a vertical line where the equal sign is. What's the opposite? What's the inverse of dividing by 3? We're going to multiply by 3, okay? Let's multiply both sides by 3. The 3's on the left side cancel out. Now I'm left with x is equal to negative 5 times 3. Remember we said one negative, my answer is automatically negative. 5 divided by 3 is 15. 5 multiplying by 3 is 15. So my final answer, x is equal to negative 15. And that's it, okay? So what's the most important question you have to ask yourself when solving for an equation? An equation is always going to represent an equal sign. So every time that you see an equal sign, that you're going to be solving for a variable. You have to isolate it. But in order to isolate, you have to move things from left to right, right to left. So you have to know your inverses. So something that you always have to remember. The inverse of addition is subtraction. What does that mean? Whenever I see something being added, I'm going to do the opposite, which is subtracting. The inverse of subtracting is addition. The inverse of multiplication is division. And the inverse of division is multiplication. And you remember these inverses, you're going to have a better time isolating these variables whenever you're solving for this equation. All right. Thank you for watching. Hopefully this helped.